Hi guys, my name is Vinay Jains. Today I'm going to talk about breadth first search algorithm in much more detail. Last video was about how the breadth first search algorithm works. We did a dry run of that and discussed the algorithm for that. I want to in this video discuss breadth first search in more detail via more examples. So this is the algorithm for that. Notice the earlier example that we did that worked for binary tree. Binary tree is basically every node has two children, left and right nodes. So that is binary tree. So this algorithm works for that. The time complexity of the general BFS for binary tree is O of V plus E, where V is the number of vertices in the tree and E is number of edges in the tree. So the time complexity is O of V plus E and the space complexity is O of V for BFS for binary tree. Now that we have discussed this, I'd like to consider some examples for better understanding of BFS. So let's say we have this example where we have a tree with node 1 and then a child node 2. Node 1 is the root node. So as we discussed, we push the root node first in the queue and then we begin our algorithm. So we pop the topmost node in the queue, assign it to pop node, check its children. How many children does it have? Does it have left child? No, it doesn't, right? Because left child is null. So it doesn't have left child. So it has a right child. So we push that onto the queue and then we have completed it's exploring the node 1 and we add it to visited set. Now we push what's next on the top of the queue. So that's node 2, right? So that becomes a pop node now. And does it have any children? No, right? It has all null children. So this node has been explored and now the visited set becomes 2. Notice first we traverse the first layer, the first level, and whatever the nodes were in it, we encountered that, and then we moved on to the next level, which is one level below, which is this level. And here whatever nodes we have in in left to right order, we traverse those in that manner and printed it. In this case we only had one node in the next level, so that was node 2. So this is essentially the breadth first traversal of this tree. Next example we have is something like this. So this example is, this is the tree. So we push the root of the tree to the queue first and we begin our algorithm. What do? We first pop the node at the top of the queue, which is this node. We pop it and assign it to pop node and check how many children does it have. Does it have left and right children? Yes, it does. So we push those left and right children both to the queue, and then since we have explored the node 1 as much as we could, we add it to the visited set. Next we pop the topmost element at the queue, which is node 3, and assign it to pop node. Does node 3, that is this node here in the tree, does it have any children? Yes, it does. What is the left child? It is 8, right? And what is the right child? It is 5. So we add it to the queue in left to right order. Notice now we pop whatever is, since we have explored node 3 completely, so we add 3 to the visited set and we pop the next one in the top of the queue, which is node 2, assign it to pop node. Node 2, does it have any children? No, it doesn't. So we add it to the visited set now. So this becomes our visited set. Note that we first started from this level. We encountered that level first. We encountered all the nodes in that level first, and then we moved on to the next level, which was this level. And whatever the nodes were in left to right order, that is first 3 came and then node 2 came. We encountered first node 3 and then node 2, and this is the level traversal for that level. Next, what do we have at the top of the queue? Node 8, right? So we pop it and start working with it. Does node 8 have any children? No, it has null children, right? So we do nothing, we just add it to the visited set. Now next we pop whatever is at the top of the queue, which is node 5, and assign it to pop node. Does node 5 have any children? Does this node have any children? No, right? So that means we have explored it and we add it to our visited set. Again, note that first we iterated over all the nodes in this level left to right, and all the nodes in this level left to right, that is 3 2, node 3, then 2, and then all the nodes in the next level, which is 8, then 5. And this is the exact order that we have received. Again, this is how the breadth first traversal works. Another example, let's say this is what we have. So we have the tree here on the left hand side. So we push the root of the tree first onto the queue. Now we start working our algorithm. We push whatever is on the top of the queue, assign it to pop node, check its children. Does it have a left child? Yes, add it to the queue. Does it have a right child? Yes, add it to the queue. We've explored as much as we could for this node. So we add it to the visited set now. We pop the next element at the top of the queue, that is 7 node, assign it to pop node, add its left and right children, left child 5, right child 4 to the queue, and add node 7 to the visited set. Pop the next element at the top of the queue, node 8. So pop node becomes 8. 8, does 8 have any children? Yes, it has. So it has what child? It doesn't have left child, but it has right child, which is 21. When we explored node 8, we add it to the visited set. Now we pop the next element at the top of the queue, which is node 5, assign it to pop node. Node 5, does it have any children? No, because it has left and right children as null, right? So we do nothing, we just add it to the visited set. Then we pop the next element at the top of the queue, which is node 4, assign it to pop node. Does node 4 have any children? Yes, it does. What all children does it have? 3 and 17. So now we have explored node 4, we add it to the visited set. Next we pop whatever is at the top of the queue, which is 21, and assign it to pop node. Does 21 have any children? No, right? So we add it to the visited set. Next we have 3 at the top of the queue, so we pop the node 3 from the queue, assign it to pop node. It has no children, so we add it to the visited set, add nothing to the queue. Now we again pop whatever is at the top of the queue, which is node 17, assign it to pop node, and since it has no children, we add it to the visited set. Again, note that we are working with breadth first search traversal or level order traversal. So we first worked with whatever the nodes were here in this level from left to right, then in this level from left to right, then from the next level, which is this, left to right, and then the next level. So essentially this was, first we encountered 1, then 7 8, then 5 4 21, and then 3, and then 17. First we encountered 1, then 7 8, then 5 4 21, and 3 and 17. So this is how the breadth first traversal works. Now in this example we're going to do the same thing, but we're looking for a target, which is 8. Target is basically this node here. So this is what we have to find in our tree. So again we'll work as we're working. So we push the root of the tree onto the node, onto the queue, then pop it, assign it to pop node, add its children to the queue, 17 left child, 23 right child, sorry my bad. Now we have done that, add it to the visited set, pop the top element of the queue, which is 17, assign it to pop node, add its children to the queue, 7 8, pop whatever is at the top of the queue. First add 17 to the visited set, then pop whatever is at the top of the queue, which is node 23, and make it pop node. 23's children are 13, it only has a right child, so we add only one node and add 23 to the visited set. Now at every point of time remember to check whether the current node that we're working, the pop node that we're working with is the target node or not. In all these cases, we didn't have the target node. So let's keep checking further. The next node at the top of the queue is 7. So we pop that and assign it to pop node. Is 7 equal to target? No, right? So we don't do anything. We just check its children, which is 10, and add it to the queue. And then add node 7 to the visited set, since we're done working with it. Next, whatever is at the top of the queue, that is node 8, we pop it and assign it to pop node. Is node 8, the pop node, equal to the target value? Yes, it is. So that means we have found our element, and therefore we return this and stop. The purpose of this example was to just show that it is not necessary every time that whenever you find the target element, the queue is empty. It can be empty, it cannot be empty. So this is just a clarification that I wanted to give. I hope you guys enjoyed this video. I hope this helped you clear your concepts. I'll attach the link for the BFS algorithm video in the link below. Feel free to check that out. I'll also attach the code for the GitHub repository for this algorithm. Feel free to check that out. Please feel free to leave your feedback in the comment section below. Thank you for your time. Have a great day.